So 5.9, we're going to talk about complex numbers. That's numbers that have imaginary parts, usually. And so like a generic complex number, if I just wrote down some generic complex number, let's just do it in crayon for fun. Let's go A plus BI. So A plus BI would be like some just generic, general case complex number. And so the deal with complex numbers is that we have a real part, and then, so that'd be a real number, and then we have, of course, our imaginary part. Sometimes the imaginary part or the real part would be 0, so you could have like a complex number that would just be like 10 would be a complex number, 10 plus 0i. But usually you think of complex as having an imaginary part and a real part. Okay, so we're going to be doing all of the 4 basic operations with complex numbers. So adding, subtracting, multiplying, dividing. Are you ready?
Yes, sensei.
There it is. All right, so if we're adding and subtracting complex numbers, you just need to basically combine the real parts and the imaginary parts. It's kind of like when you learned how to combine like terms. So if I'm going to add 4 plus 2i plus negative 6 minus 7i, I take the real parts and I add them. And so 4 plus negative 6 is negative 2. And then I take the imaginary parts and I add them. And 2i minus 7i is minus 5i. There you go. So your final answer, negative 2 minus 5i. If you have a subtraction, like if you're subtracting a complex number, you have to be careful to distribute the minus to all those terms. So really it's a minus minus or a plus 2 and a minus a negative 3i, which is a plus 3i. So distribute that negative through and then combine your real parts and your imaginary parts. So 5 plus 2 is 7. Negative 2 plus 3i is positive 1i. So 7 plus 1i. Yay? Yay, nay? Eat some hay down by the bay? Just may. Don't forget to distribute the negative, so really it's a minus 3 and a minus 5i. Combine that with a positive 2i, we get negative 3 minus 3i. Yep. Because if you go back to the previous slide, the general form is like a plus bi, you know, so usually it's always the real part plus or minus the imaginary part. And a lot of times, like, where do we get imaginary parts from? We get them from roots, right? So like you would get an imaginary number potentially from like something like 2 plus or minus the square root of negative 8, right? Which really that's going to be 2 plus or minus 2i root 2. After you simplify it, right? So like usually that I part comes second like that. All right, gets a little more difficult or a little trickier when you multiply. So if I'm multiplying i's, I might end up with an I squared. So here we have negative 2, which really this is 0 minus 2i. But no one ever writes the 0 part. And if you like have to FOIL a 0, it doesn't do anything. So you might as well not write it out like that. So this ends up just being just like a distribute. So negative 2i times 2 is negative 4i. And negative 2i minus 4i times negative 4i is a positive 8i squared. Now we have to figure out what does it mean to have an I squared. Dylan? All right, let's break it down here, Dylan. So I is equal to I. That's kind of dumb, but where does I come from? What's the definition of it? It's the square root of negative 1. Good. So now if I have I squared, that's going to equal, well, by definition, that's negative 1, square root of negative 1 squared. So if I square a square root, what happens? Square root and the square cancel each other out, and so I'm left with just what's inside, which is negative 1. So I squared, by definition, is negative 1. So anywhere you have an I squared, do not leave it as I squared. I repeat, do not leave it. I repeat, do not leave it as I squared. So what do? Drop the I squared and change the sign. That's all. Right? Because what is I squared? Negative 1. So this is 8 times negative 1. So all you end up doing is drop the I squared and change the sign. That's it. So now this is going to be a negative 8. So it's negative 8 minus 4i. Don't you know? I forgot how much I like this calligraphic pen.
Yeah.
This one we got to FOIL out. So first ones, 3 times 4 is 12. Last terms, 3 times negative I is negative 3i. Middles, 6i times 4 is 24i. And the last terms, 6i and negative I are negative 6i squared. So in this case, we had to do kind of a little FOIL or double distribute, and we have an I squared. So what do I do with that? Drop the I squared, change the sign. So really this is a positive 6. So when I add that to 12, I get 18. And then 24 plus negative 3 is plus 21i. Right. Good. So never leave an I squared in your answer. Always just change the sign and drop the I squared. Okay. You might see some higher exponents on an I than 2, like a 3 or a 4 or 5 or 6 or 7. And so there ends up to be like a little pattern here. So let's continue with this I squared, I cubed business. I cubed is the same as I squared times I. Well, I squared we know is negative 1, so this is like negative 1 times I, which ends up being negative I. I to the fourth is the same as I squared times I squared. Well, I squared is negative 1, so that's like negative 1 times negative 1, which ends up being just 1. So there's a repeating pattern here. If you start with I to the fifth again, that's I to the fourth times I. Well, I to the fourth is what?
1.
It's just 1, so that's 1 times I, so it's I. So the pattern then always goes like this. It goes I to the first is I squared is negative 1, I cubed is negative I, and I to the fourth is 1. So it goes like that. I, negative 1, negative I, 1. If you start over at I to the ninth, then it goes I, negative 1, negative I, 1. Yeah.
So if you had like 3i to the third, would it change to negative 3i?
Yeah, so good. So the question was if you had 3i to the negative, wait, you say negative? To the third, right? I to the third is the same as negative I, right? So this is like 3 times negative I, which would be then be negative 3i. Yep. So you never should have an I squared or higher exponent in your answer, because an I to some big exponent is always going to be either I or just a negative 1, which changes the sign, or a negative I or a positive 1. So it's always, you should just have an I or a negative I, right? You should only have I to the first power in your answer. So if we look at a few examples of these, if you have I to the seventh, you really want to find out how many I to the fourths there are in that. So how many I to the fourths are there in I to the seventh? right? So this is like I to the fourth times I to the third. And we're trying to find how many I to the fourths there are because I to the fourth is just the same as 1, so 1 doesn't really do anything, so you can just kind of forget about it. So technically this is just like 1 times I to the third. What is I to the third? Negative I, right? So this is the same as negative I. So I to the seventh is the same as negative I. It's the same as I to the third. So really you want to find out like how many 4's go into your exponent. So I to the ninth is the same as how many I to the fourths? If I were to be very thorough, I'd say, yep, that's I to the fourth squared times I. I to the fourth squared is I to the eighth, and I to the eighth times I is I to the ninth. I to the fourth is just 1. 1 squared is 1, so all of this just ends up being 1. Who cares? 1 times I, that's just I. So you really only care about the remainder. It's like, how many 4's go into 9? 2, but you really only care about the remainder. So the remainder was 1. So the remainder is what you have left. So how many 4's go into 22? So here's kind of what, here's me, right? Here's what I'm thinking. So I'm really thinking 22 divided by 4, what's the remainder? The remainder is 2. So now I know that that's the same as I squared. Why is it the same as I squared? Because technically it's I to the fourth to the fifth, right? That's the 20 i's, and then you have the 2 left over. So what is I squared the same as? Negative 1. So I to the 22nd is the same as negative 1. Now you might have a number out in front. This is kind of what Kate was talking about. If you have 8I to the 77th, well, how many 4's go into 77? Well, 24's is 80, right? And if I go 1 back, that's 87, or sorry, 86, 76. So that would be 19, I believe. So 19, remainder 3. What are you talking about, Mr. Boyle? I just did 77 divided by 4, and I got 19 remainder 3. That's what I just did. Is that right? Or is it remainder 1? Remainder 1. Thank you. So 19 times 4 is 76. We have a remainder 1. So this is the same as 8. I'll be thorough on this one because that one got a little confusing, but it's 8I to the 4th to the 19th. That doesn't really mean anything, but that covers 76 of our i's. So that's 76 i's, and the last one I just write out here is I, right? So all that is the same as 8I. Right? Because I to the 4th is 1, so that's like 1 to the 19th. Well, 1 times 1 times 1, 19 times is just 1 still, so it doesn't matter. Makes sense, hopefully. This next one's kind of a super duper big one, kind of silly. I to the 803rd. Okay, how many 4's go into 800? 200 with the remainder of 3. 803 divided by 4 is basically what I'm doing. That's 200 remainder 3. So the remainder 3 is what I really have left. So this is like 5 times I cubed. I cubed is negative I, so that's the same as 5 times negative I, or negative 5I. So what you really have to know when you're doing this is you have to know that I is I. That's kind of dumb. I squared is negative 1, and I cubed is negative I. Those are the ones that you're going to have in your answer. You're going to either have a I, an I squared, or an I cubed. If you have an I to the 4th and it's a perfect factor of 4, then it really doesn't matter. Kind of like, you know how goalie numbers in hockey are usually number 1? I don't know why. So you have like the goalie number on their jersey. And instead of on the jersey, instead of on the jersey, it says what was I doing? Oh yeah, I to the 4th as their number. That's just 1, right? That'd be neat. You could also put on there I to the 20th. That's the same as 1, because it's I to the 4th to the 5th, right? That'd be neat. It's new goalie jersey, imaginary number night. All right, let's wrap this up. Here's another one you could try on your own. We just did 4 of them. Do you want to do another one? All right, we'll just do number 6. I like number 6. It has a number in front. So I to the 14th. How many? Let's see. Hey, hold on. Let's see if can we quiz Mrs. Rasmussen? Oh no, she's leaving. Okay, how many 4s go into 14? Yep. 3 with the remainder of? Did she say 2? Good job. All right, 2. So she got it right. Nice job. So this is like negative 6, I to the 4th to the 3rd, which doesn't matter, and then I squared is what's left. I squared is the same as negative 1. Drop the I squared, change the sign. So this is all the same as positive 6. Okay. All right, let's move on to the last part. Dividing, we can't have a imaginary in a denominator. It's improper. So what we do is we have to do something. We call this multiply by a conjugate. So what is a conjugate? That's the question. Well, a conjugate is like a plus bi and a minus bi. It's kind of like when they have the same real parts but different imaginary parts. A lot like when you do the difference of squares. When you do the difference of squares and the middle term drops out, one's like x plus 5 times x minus 5, and you just get x squared minus 25. It's like that. So that's what's going to happen here when we multiply by the conjugate, is the imaginary stuff's going to go away. This first one's a little bit kind of sneaky because 8i is the same as 0 plus 8i. So what's the conjugate of that? 0 minus 8i. But does anyone write the 0? No. So you can just multiply this one by negative 8i over itself, negative 8i. You know, and everything's fine. That's totally legal. There's nothing wrong with that. Okay, it's just like multiplying by 1. Not breaking the laws here. Distribute. I'm left with negative 24i minus 56i squared all over negative 64i squared. So now we can clean that up a bit, and we have in the top, if we have an I squared, we drop the I squared, change the sign, so that's going to be 56 minus 24i all over positive 64. And that's kind of neat because we can factor out, I think, an 8. So undistribute an 8 and factor out an 8 in the bottom, and you can reduce a factor of 8 in the numerator and denominator. If I take an 8 out, I have left a 7 there and a negative 3i there. So that final answer would be 7 minus 3i all over 8. Who votes that that's slick? 1, 2, 3, 4, 5. 5. That's it. 5. What's the conjugate of 2 minus 4i? 2 plus 4i. That's good. So all you do is change the imaginary part, keep the real part. Every time you multiply a complex number by its conjugate, the imaginary stuff is going to go away. So in the denominator, I'm not going to have any imaginary stuff. In the numerator, I might. Let's see. FOIL it up. 10i, not 10i, silly. 10. So 10 plus 20i plus 2i plus 4i squared all over 4 plus 8i minus 8i minus 16i squared. And this is what happens in the bottom here. You always get that to cancel out like that. This changes the sign and drops the I, so the bottom numerator is going to be 20. Excuse me. And the top, change the sign, drop the I there. That's a minus 4, so we're going to have 6 plus 22i in the numerator. And you can go ahead and factor out a 2 there. So take a 2 out of each one of those. I'm left with a 3 plus 11i. Take a 2 out of the bottom. I have a 2 times 10. And then I can go ahead and get rid of those common factors in the top and bottom of 2. So my final answer is 3 plus 11i all over 10. Know what I mean? Know what I mean, Broccoli Man? I know what you mean. All right. 4 days left till Christmas break.